Pretty weak. Good morning, everybody. Today we're going to do what we're going to talk about today are the principles, the properties, and the patterns of math. Yes, mathematics is a language. As we read the equations, the expressions left to right, like we don't do a textbook line. But there are rules about how we interpret what we read in mathematics. Let's first talk about the properties. The first property is a commutative property of, there are two parts. What does commutative mean? What does to commute mean? It means to move. Whenever you drive, move from one place, you're commuting. Mathematics has the same rules there of how we move things in an equation. So the first one we have, first commutative property is of addition. The first rule says this. If we have two numbers, X and Y, I don't care what they are, it could be anything. I can move them around. X plus Y is the same thing as Y plus X. Three plus four equals 4 plus 3. Doesn't matter which order they're in. I can move them around if I want to. They both equal 7. The second commutative property is that of multiplication. What that one says is X times Y is equal to Y times X. 3 times 4 is the same thing as 4 times 3. They both equal 12. So that's the commutative. In other words, we're going to move them around as we want to, as we need to. The second property is the associative property of to associate means to form groups. So the first associative property is that of addition. What it says is X plus Y plus Z is equal to X plus Y plus Z. That's true, isn't it? No matter what they are. If X plus Y plus Z is equal to X plus Y plus Z, that's just mirror image. But here's the problem. There's nothing in our known universe that could process more than 2 bits of information at any one time. If I give you three numbers, 3, 4, and 5, I ask you to add them, what you're going to do first is take the first two, add those together, and add the third. Computers do the same thing. So this is where we introduce the concept of parentheses. The parentheses tells us, okay, since we can't do more than two pieces of information at one time, which two do we do first? And that's what the parentheses are all about. This is where we introduce parentheses into equations. For example, we have 3 plus 4 plus 5 equals to 3 plus 4 plus 5. So on this side, what do you do first? On the left side? Inside the parentheses, right. So we're told to do this first. 3 plus 4 is 7. And then we can do 7 plus 5 is 12. We do the same thing on the other side. So we have to do the parentheses first. So we have 3 plus 4 plus 5 is 9. 3 plus 9 is 12. Yes, it's not too impressive. It becomes more apparent the next example. With the associative property of multiplication. What this one says is if we have three numbers and we multiply them, oops, this is z, I'm sorry. X times y times z, we can tell which ones we're supposed to do first by the parentheses. So we have 3 times 4 times 5, 3 times 4 times 5. So go ahead and work these out and tell me which side is easier to do, at least to you. So what's the answer? Which side is easier to do? Very much so. Because on the left-hand side, the first thing you have to do is inside parentheses, 3 times 4 is 12 times 5. On the right-hand side, 4 times 5 is 20. The left-hand side, we have to do a lot of moving around. 5 times 2 is 10, carry the 1, and so on and so forth. The more things you have to do, the more writing you do, the more chance you'll have of mistakes. On this side, all you have to do is 3 times 2 is 6, and it ends in a 0, so you have 6. So by far, the right-hand side. So this is the beauty of the associative property. If I gave you three numbers or multiple numbers to multiply together, you can pick whatever ones you want to together and multiply those first. And then whatever you have left is the easiest process. The third property. The distributive property. If you notice on the other properties, I separated the addition and multiplications separately because they each had their own. Now the distributive property, we put them both together. This is probably in the property wise, this is the most important one because we combine both multiplication and addition at the same time. So we have some number A times whatever the sum of x plus y are. That's great if A, X, and Y all have numbers. But let's say that Y was a number and A was a number. We can't add X plus 4 or X plus 5. So we have to get rid of the parentheses. That's what this property is all about, is to get rid of the parentheses. The number in front of a parenthesis or in front of a letter is called a what? What is the name of a number in front? Very good. Yes. It's called a coefficient. What this thing says, it's A times. How do I know it's times? Multiplication is the only operation that doesn't need to be there to be there. Addition, subtraction, always have to have those little symbols there that tells you what to do. You can't have, I can't give you two numbers like this and expect you to say, okay, I'm adding those. There's nothing between there that implies that it's multiplication. So multiplication can be written this way: x dot y, xy, xy, x times y. All of those mean the same thing. All right, so what this says is whatever the coefficient is, I have to multiply it to each term inside there. So a times x, since a is positive and that's positive, the sign is going to be positive, then a times y. As I said last time, the thing that'll ruin most of your grades is that little symbol there, the minus, the negative sign, the minus sign. So that's why whenever you do equations and you do processes, always do the numbers to numbers and signs to signs. You can never go wrong that way. Now, the beautiful thing about this equation here, let me just give an example. We can do it two ways. Since we can do the inside the parentheses, we can do that. We get 4 plus 2 is 6. 3 times 6 is 18. If you can do inside the parentheses, go ahead and do it, and then do the coefficient. Or if you wanted to, you could distribute. 3 times 4 plus 3 times 2. 3 times 4 is 12. 3 times 2 is 6. 12 plus 6 is 18. And it works. But the beauty of the distributive property is, let's say we had that. Can you do inside the parentheses now? No. So we have to get rid of the parentheses. That's the whole purpose, well, one of the main purposes of the distributive property. 3 times x is 3x. Positive times positive is positive. 3 times 2 is 6. So that's what it looks like now. The distributive property does more than that, actually. How many of y'all took chemistry before? Yeah, so in chemistry, an equal sign actually means the equation should be able to go both directions. We just went from here to here, like that. The beautiful thing about this is the same property tells us we can go from here to there. So with distributivity, Let's put numbers here. So we get 3x plus 3y. That's distribute. That means that the coefficient is being distributed inside there. We can now go the other direction. If I give you this equation, I should be able to put it in this form. What do they both have in common? A 3. Since that's all they have in common, everything else goes inside of parentheses. If I take away the 3's, all I have left is x plus y. That is called factoring. That's going to be the largest part of this course is factoring. So here's another example. Factor that one out. What do they both have in common? What is 15 made up of? What two numbers multiply to give you 15? 3 times 5. So this equation really looks like 3 times 5 times x. Now what do they have in common? They both have a 5. Since they both have a 5, I can take it out. So I take out the 5. What do I have left? 3x plus y. Again, we're going to spend a whole bunch of time in the semester doing this, but this is the beauty of this property. It helps get rid of parentheses. It helps you put parentheses in where you need it. The next property. The inverse property of, what does inverse mean? What is inverse? Another name for inverse is opposite. So the inverse property of addition basically what I was looking for is, what do I have to add to x to make it disappear? What's the opposite of x? Very good. Negative x. Basically, if you think about this in a number line, we have negatives to the left, positives to the right. The opposite of 2 is negative 2. The opposite of negative 3 is positive 3. So just change the sign. That's an addition property. The inverse property of multiplication, what times x gives me 1? No. Because if I had 3 times negative 1, I would simply have negative 3. Good try though. I mean, that's what we did up here. Basically, the inverse is how do we get rid of something? What's the opposite of a multiplication? Division. So what the inverse would be, it would be 1 over x. It's the flip of whatever you're multiplying by. Because the x's cancel, we're left with 1. So every fraction, every number is a fraction. X, every number is a fraction. It's over 1. So the opposite of x over 1 is the flip. So opposite equals the flip. Since this is x over 1, I flip it and multiply to it. So what's the opposite of 2 over 3? 3 over 2. That's the inverse. Now, why would we use the inverse property? What's the purpose? Yeah, so eventually what we're going to be doing is we're going to be working on equations. We're going to work on equations. We're going to be asked to solve for x. We have to get rid of the 3. How do you get rid of the 3? Yes, do the opposite. We have to do both sides. Why both sides? Yeah, because the equal sign is a balance beam. Whatever you do to one side, if I'm doing a -3 here, I got to do a -3 here. So those cancel out. We're left with x equals 5 minus 3 is 2. Yes, it seems basic. It seems rudimentary, but trust me, a lot of students throughout the course, the term of this course, you'll make those mistakes. So yeah, it seems Mickey Mouse right now, but I'm going to give you much larger and larger equations to deal with, where you have to go back and think each step by step by step by step. And the last property that we're going to talk about is the unity property. Of addition. Another name for unity, we can call it the identity property. How do we keep it to itself? To make it, what do we have to multiply or add to something so it stays the same? So what do we have to add to x to keep it as x? Very good. A 0. So the identity, the unity number of addition is 0. Basically, if I add 0 to anything, nothing changes. But actually, this brings us to another property. This brings us to the inverse property. How do I solve for 0? What do I have to get rid of? X. How do I get rid of the x? So that's what we just did in the inverse property. X minus x gives us 0. X minus x gives us 0. So this brings us into the other properties we discussed. And the unity of multiplication, what times x gives me x? Yes, it's not x, because if x times x, if x was 4, it'd be squared. Yeah. Yeah, all of these, again, these are very important. These are very, very important because we can't do anything in math without these. The next part we're going to talk about are the order of operations. Yes, all those properties we talked about are worthless unless we know when to do them. The order of operations tells us when we can do something. Okay, I know most of you all, if not all of y'all, memorized this mnemonic called PEMDAS. If you didn't, good. In my classes, this is never brought up, never discussed, because it's very limiting. In order of operations, we go from the most complicated to the most simple. The first thing we do are always special operations. I mean, if you look at, remember Isaac Newton, when he invented calculus, it was all for the military, for their cannons. Well, look at this. Before any battles ever done, they always send in special operations, the special terms, special groups. What are special operations? Parentheses, brackets, exponents, absolute values, radicals, nth root radicals, square roots, and factorials, integrals, derivatives. There are over 400 of them. I can tell you right now, most of y'all, if not all of y'all, hadn't seen most of these other ones. For example, what does this symbol mean? It means just scream out the letter N. N, no. It's called a factorial. It's called a factorial. It sounds impressive. It's used in statistics. It's a counting technique. What it really means is take whatever number's in front and multiply it down to 1. So 3 factorial is 3 times 2 times 1, which is 6. What would 5 factorial be? Five times 4 times 3 times 2 times 1. So you start at 5. So let's see. 5 times 4 is 20. 20 times 3, 60. 60 times 2. I'm glad you're answering out, because everybody else is chicken. But yeah, that's all it is. And so that just says multiply everything. We have another symbol in mathematics called the summa. This one tells us to add everything together. So this one tells us to multiply. This one tells us to add. Sum, summa, the first 3 letters of the word summa means add. So you first do the operations, special operations. Then, as you get those done, you do multiplication and division. Then lastly, you do addition and subtraction. Notice that they're in the same levels. Doesn't mean that division is more important than multiplication, or multiplication more important than division. Mathematics is a language. We read the equation from left to right. And we do whatever process we have to as we read left to right. Of course, the first things we look for are any special operations. Are there any special operations across the entire equation? If no, then we look for any multiplication divisions. Whatever we get to. Did I give you this question last time? No, other class. Oh, it was my calculus class, and most of them missed it. What's the answer here? I'm glad you both said that. It's either 9 or 1, but it can only be one answer. According to the order of operations, are there any reading left, right? Are there any special operations? No. Reading left, right. Are there any multiplication, division? We do division first. 6 divided by 2 is. Now, read left, right. Any special operations? No. Any multiplication, division? Yes. 3 times 3. And then because that's exactly, I can tell exactly whether you use PEMDAS or not in the process. And don't feel bad. I gave the same questions to a graduate class, and half of them missed it because of the same logic reasoning. Some of y'all will take 2 times 3, which gives us 6. 6 divided by 6 is 1, which is not right. So we have to learn how to read our equation from left to right. We're going to do a whole bunch of these. Whenever I do examples, I'm going to go through, I'm always going to refer back to the order of operations. Let's go put some bigger ones on here for practice. Actually, let's make it. There. Go ahead and work that one out. So mute. All right. Order of operations. What's the first thing we do? What do we look for? Yeah, special operations. Read left to right. So we have a bracket here. It starts here and it ends there. That's the reason we have brackets and parentheses. It's that way we can separate which ones we do in which order. So now that means we do inside here. Read left to right. Any special operations? So we do these first. So there's nothing, we have to do that first. So we got 2 plus 3. 5 plus 3 is 8. So that's the first thing we do. Repeat the process. This is exactly what computers do. They do one thing at a time and it repeats the process each time. Left to right. Here's a bracket. We have to do inside there. So inside there, left to right. We can't do anything inside there. So we go to the next process. Any multiplication, division? There's multiplication. Remember, multiplication doesn't have to be there to be there. So we have to do this. So we got 2 plus 3. 2 times 8, 16. Minus 5. Repeat the process, left to right. Special operations. So we do inside there. No special operations, no multiplication division, but there is addition. 4 plus 16. 20. Read left to right. Any special operations? Yes, but we can't do anything inside there. There's no operations. It's just a number. So any multiplication division. So 3 times 20 is 20. Repeat the process. Special operations? No. Addition, multiplication division? No. Addition, subtraction? Yes, here's addition. 2 plus 60? No special operations, no division, we just have a subtraction. 62 minus 5. There. Now, where did y'all mess up? What part? That's the important part. Find out where you messed up. Oh, so it's my writing. Yeah, I apologize that, yes. It's just a combination of both. That's the reason I didn't go into English, was my writing is horrible. Oh, here? And that is there is the probably the first or second most common mistake. Most people will add these two together first. How many of y'all did that in this room? Yeah, don't feel bad because that's the majority of errors happen right there. No, that's why we should always look at those three steps. Any special operations, multiplication, division, and repeat. Always. You see how many steps I took to do this? We're gonna eventually get better, so you can do this pretty much a lot of stuff in your head. But I will always show you each step by step by step by step. I tell my classes this: it's cheaper to buy a ream of paper than it is to repeat this course. So use all the paper you need. Want to try another one? Okay. Easy, medium, or hard? Let's just give you a confidence booster first. I only have like 4 numbers on here. There. Pause. All right, left or right, we get to a bracket, our parenthesis, I mean. So that one ends here. So we do inside. Here's another parenthesis. 9 minus 5 is? So we do that first. Repeat the process. There's a parenthesis, begins and ends. So we do inside here. Can we do anything inside this parenthesis? No, it's nothing there. So 20 divided by 4 is 5. We can't do anything inside there, so we multiplication. 3 times 5. It's 15. 15 minus 12, 3. And to be honest, all of them, no matter how big I give you, it'll be the same simplicity. Once you follow the rules, it's a piece of cake. Some rules may take longer to follow. Let me give you a bigger one here. There. I stopped because my hand got tired. And I was running out of paper. All right. Left to right. We got a parenthesis here. It ends there. So we got to do inside there. Inside here, read left to right, we get to this parenthesis. So we got to do that first. 3 minus 1 is 2. This is multiplication. We don't touch that side just yet. Repeat the process. Left to right, we got a bracket, parenthesis, I mean. We can't do anything in here. So is there any addition, multiplication, division? So that gives us that. So we have 5 times 2, which is left to right. Here's a parenthesis. 10 plus 2. Here. Look at airplane. I'm sorry, it's a 3. Yeah. Okay, thank you. It's the new math. Now what do we do? Left to right. Can't do anything here, so what do we do? Yeah, so we have negative times positive is negative. 2 times 12, 24. Get used to doing that. I'll do it all the time. Whenever I'm multiplying or dividing or adding, subtracting, I always look at the signs separately than the numbers. Because again, signs are always going to be the biggest problem when you do these problems. So that equals there. Repeat the process left to right. Any parentheses, any special operations right here. We got to do inside there. Special operations. Do those. Two times 2 is 4. Left to right, special operations. We can't do anything in here to multiply. Positive times positive is positive. 3 times 4 is 12. Left to right, here's a parenthesis. 5 plus 12 is 17. This is where it gets big now. Left to right, here's a parenthesis. We can't do anything, so we have to multiply. So we get 6 minus 24. Negative times positive is negative. 4 times 17. What's 4 times 7? 28. 4 times 1 is 4, plus 2 is 6. So it's 68. Positive, negative. So 6 minus 24 is what? Negative 18. I will go with that in a second. Why? Minus 68. Negative 18 minus 68 is negative 86. There's your answer. So, yes, we have a winner. Everybody's pretty close. So where were the mistakes? The mistakes are more important to me at this stage than the getting them right. So where did the most mistakes happen? Again, yeah, it's always going to be the biggest thing you want to do first before you multiply. Yeah, so you have to do order operations first. Yeah, that does a big difference. How'd you get 384? Where did you go wrong?
What times? You know, 6 minus 2 equals 12, and then there's no more parentheses for the 24. Parentheses, so that is 6 times 24.
Okay, okay. That would explain this big number, yeah. But see, again, that's what I'm saying is once you see what understanding where your mistake was, if you could do that, that means you understand this process. It just takes practice to get better with it. Now, so let's go ahead and another big problem we have is these. Adding and subtracting with signs. In other words, we're all okay if we had numbers like this. 3 plus 5 is 8. Or how about if we had 8 minus 5? Those are okay. The problems occur when we have these type of problems. But the fix is super easy. Here are the rules. If the signs are the same, then take the common sign and add the numbers. If the signs are the same, take the common sign, that's what your answer is going to be, that sign, and then add the numbers. Subconsciously, you did that already in 3 plus 5. Is 3 positive or negative? Positive. 5 positive or negative? They're both positives. So the answer is going to be positive. So we just add the numbers. We do the same thing with this one. They're both negatives. So the answer is going to be what? Negative. 6 plus 4 is 10. So if the signs are the same, take the common sign and add the numbers. Remember, I'm trying to get y'all to look at mathematics. The signs and numbers are different. If the signs are different, if the signs are different, then take the sign of the larger number so the answer is going to be the sign of the larger number if the signs are different. And subtract the smaller number from the larger number. If the signs are different, then take the sign of the larger number and subtract the smaller. So the bigger number minus the smaller number. That's what it means. So in our example, 8 minus 5. The signs are different. Which number is bigger, 8 or 5? So the sign of the 8 is positive. So the answer is going to be 8, positive. 8 minus 5 is positive 3. Negative 9 plus 2. What number is bigger, 9 or 2? 9's bigger, so the answer is going to be negative. 9 minus 2 is 7. Easy fix. And I can't tell you how many times that's subconsciously, even later on in this course, you'll look at numbers and it'll be so simple to you that you'll overlook it and do a sign problem. But if you break it down and step by step by step, this is what's really happening. With multiplication division. Multiplication and division with signs. If you have an even number of negative signs, the answer will be positive. If you're multiplying a whole series of numbers, count the number of negatives. If there's an even number, what's an even number? Yeah, 2, 4, 6, 8, 10. If you have an even number, then just, forget the signs now. You know the answer is going to be positive. Just worry about the numbers. If you have a negative, an odd, if you have an odd number of negative signs, the answer will be negative. So before you do anything, just count the number of signs. There's a difference between a positive sign and a plus, a negative sign and a minus. Is the answer going to be positive or negative? 1, 2, 3. Yeah, the answer is going to be negative. So we don't have to worry about the signs anymore. Now we just do the whole process of multiplying and dividing. We don't have to worry about the signs anymore. So the 3's cancel. The 5 cancels. The 4 cancels. So all we have left is 2 times 2, which is 4, over 9. And there's your answer. So yeah, mathematics breaks down to simple processes like that. So that's what I'm saying. That's why a lot of times you don't need calculators. Just look at them and figure out the easiest way to put them together. When we talked about the properties, we always talked about properties with addition and multiplication. What about subtraction and division? Can we do the properties work for subtraction and division? The properties, the commutative, associative, distributive. Do division and subtraction, does it work for them? No, actually, no. We're not doing this. Because remember, I should have done this earlier. Remember the commutative property, which was x plus y equals y plus x. Does that work with subtraction? 3 plus 4 equals 4 plus 3. They both equal 7. X minus y equals y minus x. Does that work? Let's see. 3 minus 5 equals 5 minus 3. What is 3 minus 5? Negative 2. Because 5 is bigger, it's negative. 5 minus 3. Are they equal? So the properties do not work with subtraction. The properties do not work with fractions. I mean, with negatives, with subtraction. That's because subtraction doesn't really exist. Computers cannot subtract numbers. They can add numbers, which means what a subtraction is the addition of a negative number. That's what subtraction really is. It's the addition of a negative number. So 3 minus 5. What this really means is 3 plus negative 5. If we look at it this way, does commutativity work? Does that equal negative 5 plus 3? Are they equal? Yeah, they both equal negative 2. So what this rule tells us here, you cannot use subtraction in the properties, but whenever a number has a negative in front of it and you move it around, that sign has to stay with that number. The sign remains or stays with the number. Since the negative is in front of the 4, it always stays in front of the 4 when I move it around. The 5's positive, so if I move them around, I get the same answer. So the sign, if there's a negative in front of the 4, it stays with that 4 no matter where I move it. Now it works. How about division? Does division work with the properties? Correct. Yeah, because it wasn't there earlier. Why doesn't it exist? Because it's the opposite of multiplication. So our properties x times y, y times x. Does that always work? No. Because division is already a reciprocal of itself. So whenever we talk about the properties, we talk about addition, subtraction, addition, multiplication, and with subtraction and division, we have to do a whole set of different rules. You have to be very careful about them. So far, so confusing? We're almost done for today. Actually, went through the properties, those Oh. No, we did that already. Actually, I did for today. That gives us the basis, the foundation of mathematics. The order of operations. We're gonna do a couple more before we leave, but you have to always remember those basic rules. In any level math course you ever take, these rules always have to apply. You cannot do anything in math unless a rule says you can do it. So that's why you never change signs, because they look better. Let's combine our work here. This is your exit ticket. You can leave once you solve it and show me the right answer. And you can't share with your neighbors.